folks, welcome back to physics. In this video, you are going to learn about how to add and subtract vectors. By the end of this video, you'll be able to add and subtract vectors in one dimension. So first of all, adding scalars, something very easy, something you've been doing for a long time, right? That'd be something like 2 plus 2 equals 4, 1 plus 3 also equals 4, 7 plus 6 equals 13, and so on and so forth. Adding vectors, on the other hand, is not. Why? Because direction makes things complicated. So taking 2 steps forward and 2 steps back is going to be added differently than taking 2 steps forward and another 2 steps forward, which is going to be added differently than 2 steps forward and then 2 steps to the left. So we're going to be talking in this video about how we add vectors. And I'm going to go ahead and start by talking about adding vectors in one dimension. So by that I mean moving left or right and not up or down at all. So in this problem we have Jim here, and Jim is going to walk 2 meters to the right, stop, and then walk another 4 meters to the right. So what I've done is I've gone and I've drawn my vectors for my first 2 meters to the right, and then my second 4 meters to the right. And the way that I'm going to add my 2 vectors, which I'm going to name vector A and vector B, the way I'm going to add them is by writing them out head to tail like I did in this image, and then just seeing how far away from 0 I am. So I started at 0, it's going to be one end, and I ended at 6, my other end. And so Jim, his new position is going to be 6 meters to the right. And you can see that I solved this problem by drawing a picture, and most importantly by lining my vectors up head to tail. So the tail of the first vector is next to the head of the second. So let's go ahead and try another example. So in this one we have Dwight, who's going to walk 2 meters to the right, stop, turn around, and next walk 4 meters to the left. So let's go ahead and draw those vectors into our picture. So we have Dwight starting at point 0, and he's going to walk 2 meters to the right. And so there's my first vector. I've got my head and my tail of my vector. Let's go ahead and then put in our second vector. And again, we're lining them up head to tail. So I'm starting at 2 meters with one end, and then I'm walking 4 meters to the left. So instead of pointing my vector to the right, as I did in my first problem, I'm going to draw it with my arrow pointing to the left. So we're going to go ahead, left 4 meters. And then I'm going to see where I am in relation to where I started and draw my resultant vector. So I started at 0, and I ended up at -2. And I know this, the way I know how to draw the direction of this vector by starting where I started my first vector and ending where I ended my last vector. And so this vector is -2 meters. So Dwight's final position is -2 meters, or a little bit more clearly, 2 meters to the left. And one other interesting thing you can see in this example is that we can use the sign on our vector, the positive or negative sign, to show our direction. So if he is 2 meters, he's 2 meters to the right. If he's -2 meters, then he's at a position 2 meters to the left of where he started. So there you have it. You have learned how to do vectors in one dimension. Okay, so you guys have learned how to add vectors. Now let's talk about how to subtract vectors. So example 3. What is 2 meters to the right minus 4 meters to the left? I'm going to go ahead and I'm going to circle that minus because that is super important. So the real trick is when we subtract one vector from another, what we're going to do is we're going to go ahead and just flip the direction of our second vector, the vector being subtracted. So normally when I add 2 meters to the right and 4 meters to the left, what my picture will look like is this, as you just saw, and we'll end up at -2 meters. But we are flipping our 4 meters to the left. So what that means is that this is not right. Instead, I'm going to take my vector, keep the length of 4 meters the same, but flip its direction. So I'm going to draw it head to tail again, still, but going to the right, because the subtraction sign here, that minus sign, means flip the direction of my vector. And so what I'll get is that 2 meters to the right minus 4 meters to the left gives me a final vector, when added together, of 6 meters to the right. I can also depict this just using my signs. So if I decide with my frame of reference that to the right is positive and to the left is negative, then what I can say is that 2 meters to the right is just positive 2, and from our positive 2 we are subtracting 4 meters to the left, or negative 4, giving me my final vector, which I'm going to call C, as C equals 2 minus negative 4, or C equals, again, 6 meters. And I don't need to put that to the right in there, because from my frame of reference here, I know that to the right, that a positive sign means that I'm moving to the right. So, again, when you subtract your vectors, just flip the direction of the vector, either change the sign, or just flip the direction that your arrow. So let's talk takeaways. First of all, vectors are added head to tail. Secondly, when you subtract vectors, you just flip the direction of the vector being subtracted, and we saw that in the previous example. And finally, we can use the sign of a vector to denote its direction, as long as we show somewhere in the picture which direction is positive and which one is negative. So there you have it, guys. You now know how to add and subtract vectors in one dimension. Go ahead and see if you can do it on your own. Good luck and happy solving.